Okay, good morning. Am I audible, Apridi? Am I audible? Okay, good morning, everyone. Am I audible? Please confirm me. Am I audible? Ankita, please confirm me.
Yes, sir.
Okay.
Good morning.
Yes, good morning. Good morning, all of you. Okay, just 1 minute, then I will start. Okay, so good morning, all of you. So last class we have discussed in our jet transform. There are the inverse jet transform we have to discuss. Okay, and in this inverse jet transform method, we have to solve different types of procedure or different types of method in the inverse jet transform method. So now today we will discuss the another new chapter from the jet plane, that is a jet transform. It is your module 2 in the second part, that is a jet plane analysis of discrete time control system. Okay, so I'm sharing my whiteboard. So today we will discuss the chapter name is my whiteboard is visible, everyone.
Yes, sir.
Yes, sir.
Okay. Just wait. Okay, the chapter name is jet plane analysis of discrete time control system. Okay, so in this chapter we have to explain the different types of terms, that is impulse sampling, what is impulse sampling, how it is calculated. Then we have discussed data hold circuit, what is data hold circuit, and using this data hold circuit we have to solve another is zero order hold. Okay, and this zero order hold, that is a zero transfer functions, then another one that is first order transfer functions, and so on. So in our discrete control system we have to apply the zero order hold circuit, that means the zero order hold transfer function. So these are the different topics we have to discuss in this chapter also. First we have to know the impulse sampling. Impulse sampling. So what is impulse sampling? So this is basically one of the method for the continuous time signals. We know that xt is a continuous time signal. So if the continuous time signal that is x of t is impulse sampled in a periodic manner in a periodic manner, and mathematically we have to write these equations. Mathematically, the sample signal may be represented by we have to written this impulse function in mathematically form, that is x asterisk of time with respect to time, that is summation of k is equal to, you know that, 0 to infinite. Okay, this is the basically single sided jet transform method, that is x of t delta t minus kt. Okay, so this is basically mathematical form of impulse sampling method. So the impulse sampling, the switching method or switch, it may be thought of as closing instantaneously every sampling period. You know that every sampling period means that is a t. T is gap of the every sampling period, t, 2t, 3t, and so on, and generating impulses, different impulses for the different sampling period. You know that that is x of kt. You know that that is the k is the basically difference of the different impulse functions, that is k is equal to 0, 1, 2, etc. So this is the basically x of kt into delta t minus kt. The k is, you know that this k is the basically changes. Okay, so such a sampling process is called impulse sampling. Impulse sampling. So this is the basically definition of the impulse sampling. I'm again repeated. So what is impulse sampling? You know that in our control system we have to use a continuous time signal. In the continuous time signal we have to express x of t, that is with respect of t, and it is impulse sample is periodic manner. Periodic manner, that means you know that in our jet transform method we have to apply different sampling period, that is a different sampling period, that is t also, that is t is equal to t, 2t, 3t, and so on. So this is the basically periodic manner. We have to express the mathematically for the sample signals. This is the x asterisk with respect to timing. It is equal to summation of k is equal to 0 to infinite. You know that in our jet transform method, we have to consider one-sided jet transform method, that is k is equal to 0 to infinite. So that's why you have to written here the limit is k 0 to infinite xt into delta t minus kt, where k is, it is also different impulse functions or different sampling period. We have to change it. This k, that is equal to 0, 1, 2, dot dot infinite frame. So the impulse sampling, the switch may be thought of as closing instantaneously every sampling period, that is also t, it is also changes, and generating impulse functions, this x of kt, that is k is equal to changes 0 to infinite range into delta t minus kt. This is basically called, this process is called impulse sampling method. Okay, is it clear, all of you? Please respond me, is it clear or not?
Yes, sir.
Sir.
Okay, so now the function is impulse sampling method, you know, that is x asterisk of time. This is the summation of k is equal to 0 to infinity x of kt into delta t minus kt. You know that? Or that is also x asterisk t, that is, these are the different value of the k, you know that, that is first x of 0 delta t plus then x of capital T, you know that, that is also delta t minus capital T plus dot 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 and so on. Please, then x of kt into delta t minus kt plus dot dot dot. Okay, so these are the basically functions of the different k value, that is 0 to infinite. This is the equation number 1. Okay, and this is basically, here you can see this is the first 0, then t, then 2t, then 3t, then that is the kt, number of infinite rates. This is basically called the train of unit pulse. This is basically called train of unit impulse. It is expressed, that is the delta of t with respect to the time. Okay, so now we have to retain this equation delta t of t. This is equal to summation of t is equal to 0 to infinity, that is t minus 2. Okay, so here we have to express the train of unit impulse functions, which is expressed as delta t of t. Okay, so this delta t of t is the mathematical functions of the train of unit impulse functions. This is equals to k is equal to 0 to infinite delta t minus 2. Okay, so this sampler output, it is basically equal to the product of the continuous time input signal x of t. So that means the sampler output is equal to the product of the continuous time input that is x of t and the train of unit impulse, train of unit impulses, that is delta t of t. Okay, so this is the basically called the impulse sampling method. So now, what is the basically practical drawing? So now you see the diagram. So this is the xt, another one that is respected to. that is also x asterisk t, another one with respect to the different t. So now this is x of t, center point that is 0, that is t. It is the sampler, that is the impulse sampling curve, that is x asterisk t, which is the 0 and different t region. So now that is the input signal, that is the continuous time input signal. You know that the curve is this one. Okay. Now you have to convert. This is basically sampler to the impulse sampler using the continuous time signals. Here you can see, just change the color. First one, sorry, this one. First, this one, then second, and you know that this is the basically equal sampling period. That is t, 2t, 3t, etc. But this equal distributions. Gapping out of the sampling period is equal. Okay. In our diagram, sometimes it is also increases or decreases. So please consider me here. Another one, this one also. Okay, so this one 0, then this is 0 starting point 0, then t, then 2t, then 3t, 4t, and 5t, and so on. So this is the basically output of the impulse sampler functions. Now, so we have to express basically it is a one of the switch I am telling you previously. Basically, it is a switch. The symbol is this one. This is the close button or open button. Then this is the basically signals of the out. So now this is x of t. This is x asterisk of t. Sometimes it is also the function that is also xs. Sometimes it is also written here x asterisk of x. And this is the particular switch, that is the delta t. That is also delta t. So this is the basically figure of the impulse sampler. Okay, is it clear all of you? क्वेश्चन ऐसे भी आ सकता है, व्हाट इज इंपल्स सैम्पलिंग मेथड एंड व्हाट इज द मैथमेटिकल फॉर्म ऑफ इंपल्स सैम्पलिंग मेथड. तो तभी आप लोगों को फर्स्ट स्लाइड से सेकंड थर्ड स्लाइड तक ये आपको ड्राइंग करना है. इज इट क्लियर ऑल ऑफ यू?
Yes, sir.
Okay, so now next, what is the basically diagram of impulse sampler using a modulator? So now another topic is important, that is the impulse sampler as a modulator. This is a basically one examples or applications, modulator application of the impulse sampler. So in our discrete control system, we have to use this impulse sampler as a modulator. This modulator, you know that modulator, what is the function of modulator? It is modulate the signal. Okay, So you know that in your communications, you are the electrical student. So in the electronics branches, communication, one of the subject is available communication. So this is a basically one communication that is signals considering. That is a modulating and demodulating signal. So you know that simple term, that is modulator. What is the function of modulator? Modulator is basically modulate the signals into the input to the output, and this modulator, it is decrease the error of the signals. Okay, you know that when you have to use the rectifier circuit, you know that in rectifier circuit it is done for the AC to DC. You know that this is the output from the rectifier circuit, but in the corresponding the output, there are the not you have to tell 100% accuracy, you have to receive the output, the DC output. In the output, there are the percentage of 5% or 10% error is coming. This error, it is basically called the AC signal, it is coming to the output signal. So in that filter circuit, you have to use it or decrease of the level of the error. So this modulator, in that our advanced control system or jet transform method, we have to use it the modulator circuit for decrease the unwanted signals. ओके, सो मॉड्यूलेटर क्या है आप लोगों को पता चल गया है. सो मॉड्यूलेटर, इट इज बेसिकली one of the device which is modulate the signals and which is decrease the error of the considering signals. Okay, so now I am drawing you one diagram, then it is also clear idea. This is a modulator block. This is the output. This is the input is coming, and one carrier signals we have to give him. Okay. Now this is the input signals I'm drawing here, and this is the output signals drawing here, and one carrier signals we have to attach here also. Now this is a input signals or modulating signals from the input signals also, or something like that. This is a one input signal. Input. This is the carrier x of t, that is the modulating signal. Another one, this is the output x, you know that asterisk of t, that is the output, and one is the carrier signal. This is the basically diagram of the carrier input signal. Okay. And this is expressed, you know that delta t of with respect to the time. This is the modulator. So using this modulator circuit, you have to decrease the error of the modulating signals. So using this carrier signals also. So the output is coming here, particular you have to see, that is 0, then t, then 2t, okay, then again 4t, 3t, and so on. Okay, so this is the arrow of the peak of the value, and this is the negative region, you know that. So this is the particular output of the modulator signal. Okay, so this is, you know that this is impulse sampler function which is modulate the signals. It is decreased, this modulator, it is decreased the unwanted carrier signals. Okay, using this carrier. So figure name is impulse sampler as a modulator. This question is very, very important. Okay, so please note down it. Now we have to given the another equations. So go the next page. So we written the equations. First of all, you know that is the x of asterisk t, that is equals to x of 0, okay, and delta t plus x of capital T into delta small t minus capital T plus dot 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 plus x of kt into delta t minus k of t plus dot 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 and so on. So using these equations, we have to consider here the Laplace transform. So what happens? So next, consider the Laplace transform of equations of the previous equation. ये इक्वेशन को एक नंबर दे दो यहाँ पे, पहले वाला तो 1 था, this is the number 2, okay, of equation transfer of equations, that is number 2. So you have to apply the Laplace transform in the equation 2. So the equation is x asterisk s Laplace x of asterisk t, that is equals to, you know that x of 0 Laplace of delta t bracket close plus next term, you know that xt Laplace of delta t minus capital T, okay, then plus this process is continuing, that is x of 2t Laplace of, that is the delta into t minus 2t and so on dot dot dot. Okay, so now we have to written this equation. First of all, it is x of 0 plus then also x of 1 minute, x of capital T e to the power minus ts. So you have to remember the Laplace transform formula from the previous one. Okay, go through the previous semester. You have to explain the different Laplace transform functions in the control system, and whatever you have to see in the your books is available. The the Laplace transform different equation functions also. Okay, this is very much important. So please, all of you remember the Laplace transform table and Z transform table once a day. Okay, सुबह मतलब जब भी पढ़ने बैठोगे सुबह सुबह, so Z transform table and Laplace transform table इसको एक बार याद करके पढ़ाई को या दिन को स्टार्ट करो. Okay, क्योंकि ये आपका पीछा नहीं छोड़ेगा. ये Z ट्रांसफॉर्म और लैप्लास ट्रांसफॉर्म ये आपका इंजीनियरिंग में हर जगह इसके एप्लीकेशन है. Okay. So the equation, that is x of 0, then x of t, then x of 2t, etc. plus dot 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 and so on. So now we have to express this equation, that is x asterisk of s, that is equal to summation of k is equal to 0 to infinity, that is x of kt into e to the power minus kts. Okay, so you know that this k is changes, this k is changes. The k is basically, you know, that is the value of 0, 1, 2, 3 dot dot dot, because this is the basically different sampling period. Okay, so now the equation number, this is basically number 3. Now we define this e to the power ts is equal to say. So now we have to express that is e to the power ts, we have to express that is equal to z. So the equation is coming, that is equals to s is equal to, we have to consider from here, that is 1 by t log z. Okay, so we have to express this equation to the s is equal to 1 by t log z. Now equation 3 becomes, what is the equation 3? You seen that this is basically equation 3. Okay, so the equation 3 we have to written here, that is a, sorry, becomes, that is x asterisk of s with respect to the, that is s is equal to 1 by t log z. This is equal to a summation of k is equal to 0 to infinity x of kt z to the power minus 2. This is the another number, equation 4. Okay, everyone, write your own name and roll number in the chat box also. And Pranav is present. Pranav? Pranav is not present. Okay, Saurabh is present. Saurabh, are you hear me?
Yes, sir.
You take a screenshot, okay? One screenshot. Okay, so the
Okay.
equation, okay, equation 4, it is coming. So now these equations we have to express in our Z transform method. So it is the Z transform of the sequence that is, you know, that first is x of 0, then xt, then x of 2t dot dot generated from xt at t is equal to kt, where you know that is k is equal to 0, this is k. Zero, 1, 2 dot dot dot. So we may write that is x asterisk of s limit, that is s is equal to 1 by t log z, this is equal to x of z. This x of z, that is equals to this one, because you know that we have to express in our z transform, these are the different functions, that is x of t at the t equal to kt, whereas k is the value of 0 to infinite range. So the equation, these equations, so equation 4 becomes x asterisk of s is equal to 1 by t log z. This is equal to x asterisk 1 by t log z. This is equal to x of z is equal to summation of k is equal to 0 to infinity x of at z to the power minus k, where you know that z is a basically complex variable and t is the sampling period. You know that, where z is equal to complex variable and k is t is the basically sampling period, different sampling period. You know that. Okay, so this is the basically sampling period, how it is calculated, the impulse functions or impulse sampling functions from the continuous time signals. Okay, so this is very, very important. So question is coming, either it is only definitions, what is impulse sampling method, okay, or sometimes it is also guide the how to calculate the impulse sampling method in the jet plane. Okay, so that time you have to describe properly. And one important application, it is impulse sampling method. It is basically used as a modulator circuit in our discrete control system. It is modulate the signals. It is decrease the unwanted signals. Okay, using the carrier signals or carrier block, it is given the functionally output from the sampler method. Okay, these are the basically mathematically expressions. Okay, okay. The first class timing is near about 2 minutes, and again you have to join after ending this class. All of you please again join. Then another topics we have to discuss the data hold circuit. That is data hold circuit. So data hold circuit basically it is a one conventional sampler. When a switch it is closest to admit an input signals, every sampling period t. In practice, this sampling duration is very short in comparison with the most significant time constant of the plant. Okay, so this data hold is a process of generating a continuous time signal that is h of t from a discrete time signal x of kt. Okay, so this whole circuit basically it converts whole circuit converts the sample signal into a continuous time signal.